Hello, grade 6. Welcome to your Monday video. I'd just like to say again, I know the weather's amazing outside. Despite that, your guys' focus has been incredible because your assignments continue to be out of this world. So keep it up. I know it can be tough sometimes, but your guys' work overall as a class has been outstanding. I'm very proud of you. Keep up the great work. With me, as always, is my co-star, Berkeley the Wonder Dog. And as I mentioned in previous videos, there she is. Berkeley no longer works for free, so coming right at your screen there. So there you go. He's a good girl? Yes, I happy girl because I got Tritos for appearing in the video. Okay, good girl. So yeah, there's Berkeley the Wonder Dog, very happy to be paid in treats. We've worked out a contract negotiation where she gets a treat before and after the video, so she's a happy dog. And a happy dog means a good dog. So we're going to start our new math unit this week, and our new math unit is probability and number sets. So there are three key terms that I want to study with probability. The first is theoretical probability. So theoretical probability is the probability you would expect when you analyze all of the different outcomes. For example, if you flip a coin, there is a 1 in 2 chance you will land on either heads or tails. Okay? But we know that when we flip a coin, we can't mathematically see into the future. Now, mathematically, you might think, okay, if Mr. Griffin flips a coin twice, because each side has a 50-50 shot, he's going to get heads and then tails. But we know that's not the case. And why do we know that? Because of experimental probability, which is the probability that actually happens when you do the experiment. So no matter the odds, I could throw a coin in the air 10 times and it always lands on heads. It's not likely, but it could happen. Sometimes things happen that defy the odds. And lastly, mathematical probability. So how does our study of both theoretical and experimental probability relate to fractions, decimals, percents, and ratio? So today we're going to take an introductory look at these two concepts, theoretical probability and experimental probability. So I mentioned the coin. All right. So two sides to a coin, right? We have tails, we have heads. So you might think, okay, 50-50 shot, it's going to land on one or the other, right? So if I flip it twice, should be once heads, once tails. Makes sense? Okay, so all right, heads. So you might think mathematically, after the second throw, that it's going to land on tails because 50-50 shot, right? Well, okay. Jumbled it. Okay. So despite the juggling, it came up heads again. And that just goes to show you the difference between theoretical and experimental, okay? Even though theoretically it should have went heads and then tails because those are the odds, we know that that's not always the case. And that's the difference between theoretical probability and experimental probability. Theoretical is we do the best we can with the odds we have to predict something. But experimental is we actually have to carry it out, all right? Which is a very important concept, not only in math, but in life. And we'll get to that. All right, so let's get to the other part of the theoretical experimental showcase, which is a deck of cards. So within a deck of cards, there are 4 suits: hearts, diamonds, clubs, and spades. Aside from 2 to 10 numbered cards in each suit, there are also face cards, jack, king, queen, in each suit, and ace cards in each suit. So in total, there are 52 cards in a deck. So theoretical probability. If I had a deck of 52 cards and I showed them all to you, so I showed you the face of all 52 cards in a deck, okay? As I show you each card, okay, theoretically, at random, you will see 4 aces if I went through the whole deck. So how do I test my probability experiment? Well, this is where lowest terms comes into play. So lowest terms can be explained as such. if I find a number that can go into both the top number and the bottom number, I can put this fraction here, if you can see my arrow, into lowest terms. That's what lowest terms are. So let's put this in mathematical terminology. Do you guys remember the parts of a fraction? Okay, so the parts of the fraction are the numerators at the top, the denominators at the bottom. So this is just another fraction. So if I were to put it in lowest terms, is there a number that goes in evenly to both the top and bottom? And lo and behold, 4, in fact, will go into both the top and bottom number. So instead of saying 4 out of 52, I can simplify it by saying 4 goes into 4 once, 4 goes into 52 13 times. So now I can do my probability experiment. I have my theoretical probability. There is a 1 in 13 chance that I pick an ace from the deck. Okay, so theoretically, when I show you 13 cards based on the lowest terms of this idea, one of the cards that I show you should be an ace. But now we're going to do experimental probability. We're actually going to do it. So I have my deck of cards. Okay, I took out 13 cards. Theoretically, there should be one ace in here. But as we do the experiment, we don't know for sure. Those are just the mathematical odds. This is my third attempt of the video because my first 2 attempts, one of them had a joker and one of them had the rules. So that's a good lesson about proofreading before you start a teaching video. All right, so let's do our experiment. Okay, so let's see. Card number 1. Okay. Card number 2, we're looking for an ace. Card number 3, oh, no ace. There's one ace. All right, so that meets our theoretical probability. There was a 1 in 13 shot I'd have an ace. So now the question becomes, will I get any more aces? Nope. Boy, wouldn't it be something if it worked out just like that? Nope. Nope. Oh my gosh, this would be so cool. We might have the actual 1 in 13 odds. All right. 4 clubs. 8 hearts. Wow. So it actually worked out to be true. Okay, our theoretical probability of having 1 out of 13 cards be an ace actually came to light. So that shows you the value of theoretical probability, playing the odds to get the right answer, okay, or using math to make an accurate prediction. Just to show you another idea of this, okay? If I were to take a look at my 13 cards, okay, and I'm just going to go back on something here, because this I thought was pretty cool. So let's go back to the screen for a second. Okay, so there are 4 different suits: hearts, diamonds, clubs, and spades, in a full deck of cards. And each of these suits is represented evenly: hearts, diamonds, clubs, and spades. Now, despite each of the suits being represented equally, look at all the hearts that were in that selection of 13. So that would defy theoretical probability, okay? There was a lot of hearts in that selection of 13. So that would go against our theoretical probability. However, the one ace in the selection of 13 proves it, okay? Prove the theoretical probability. So it goes back to the idea, okay, that if we go lowest terms, 4 aces in a deck of 52, we break it down to lowest terms, the theoretical probability is that there's a 1 in 13 chance I have an ace. The experimental probability is actually doing the experiment. And in this case, the experiment matched the theoretical. Now, if we would have been doing it for suits, would each suit be evenly represented? No, because we had so many hearts, so that goes against it. So just further clarify this point about probability. So I was trying to think of a few real-world examples here. All right, and this is what I came up with. And I think, too, this is the importance of learning about probability. Probability can be useful in many areas of life: athletics, business, science, etc. And we'll talk about those specific examples as we go on. But it doesn't necessarily offer all the answers. We do learn through studying, planning, processing, just like we did with lowest terms in that experiment. But we also learn by doing. So let me give you an example, just some random examples that came to mind. So my favorite team, the Toronto Maple Leafs. Their defenseman, Morgan Rielly, when he was 24 years old, they gave him a 6-year, $5 million per season, $30 million contract. And a lot of people said, oh, wow, that's too high. Mr. Griffin, what Toronto's spending all their money on this one player. He's too young. It's too long a term. He doesn't deserve all this money. But after they made this signing, Morgan Rielly, his statistics went through the roof. He's probably one of the top 5, top 10 defensemen in the leagues now. And this salary is considered a bargain. So his statistics didn't necessarily warrant this big a contract. Some of you may argue no one warrants this big a contract, like my dad, who thinks athletes are overpaid. But when you consider, revenue and advertising and all that, to be an athlete in today's world means you make a lot of money in some cases. But that's beside the point. The point is, statistically, the probability of Morgan Rielly earning this salary wasn't high. But the Maple Leafs took a chance on him anyway, because they saw hidden talent. They saw development. They saw what kind of player he could be. Okay, so let's take a look at social studies examples. The Louisiana Purchase. In 1801, the United States of America purchased a piece of land called Louisiana from France. And they purchased it for $15 million. Now, let me show you what that piece of land turned out to be. All right. That was the Louisiana Purchase. North Dakota, Montana, Wyoming, South Dakota, Nebraska, Iowa, Missouri, Arkansas, Oklahoma, Colorado. Just the amount of revenue that these states have made for the U.S., the amount of power it's given them and natural resources, it's incalculable. So in the early 1800s, when Thomas Jefferson paid $15 million to France for all this land, people thought it was crazy, because in the 1800s, all of this was wilderness. Okay, there was no established settlements. Okay, but he purchased this piece of land knowing that as it became part of the United States, it would be profitable. And it turned out to be one of the greatest investments in human history. Confederation. Okay, BC joined in 1871. Why did they join Confederation? Because they had a lot of debt. And a lot of people thought Sir John A. Macdonald didn't know what he was doing when he offered to pay down BC's debt to buy BC. But he looked past the theoretical probability, and he actually just did it because he thought down the road it could be profitable. He took a chance that adding BC and giving them a railroad and paying off their debt would be beneficial long time. Auditioning for musicals. Sometimes students in high school, they'll look at all the people auditioning and they think the odds of me getting a part are not good. But you know what? You never know until you audition. So that's what I'm trying to teach you guys about theoretical probability and about experimental probability. Is it's great to look at all the information. It's great to collect data. You want to make informed decisions. But it's not always the case where math can give you a definite answer. It can give you a great picture. However, it doesn't necessarily give you the whole picture. So it's a fine line. So that's just our introductory lesson to theoretical and experimental probability. I just tried to show you at the end too some real world examples of how theoretically an idea may have seemed ill-informed, turned out to be really good, even though the odds were against the person making the decision. But again, there are times when you want as much informed data as possible. So that's the tricky thing with teaching this unit is probability is a great tool to have. It's just not the only tool. All right. All right. So that's our introductory lesson for probability. I hope we have another great week. We are going to, on Wednesday, have another chat on our same site. It won't be open till 11. So yeah, there'll be information to come about that. But yeah, again, you guys have done amazing job with your work thus far, and I'm incredibly proud of you, and I hope that you keep it up. So there are introductory Prodigy questions to probability posted today. As you watch this video, take notes on the terms, maybe get a deck of cards, maybe figure out some probability questions for yourself. Okay, so that's it for today. Mr. Griffin out. Have a good day.